everybody. I'm Alberto, and this is my colleague Daniele. We are the MATLAB ambassadors here at Politecnico di Milano. I don't know if so many of you knows us from the previous year. This year, we're still the MATLAB ambassadors, so welcome to our second event. Let's say the first one that is open to everybody that already knows MATLAB. Today we're going to have the event in English instead of in Italian as the last time. So welcome everybody. Today we're going to speak about create your app with MATLAB App Designer. I don't know how many of you already knows this application. Let's do a little survey. How many of you knows MATLAB App Designer? Raise your hands. So very good. This could be a very interesting event for everybody. So let's move on and start a little bit speaking about what is our figure here in Politecnico di Milano. Of course, there's MathWorks, so the company that produced the MATLAB software. There's the Politecnico di Milano, of course, our university, and then there's us. We are mainly related to two big focus. The first one is to have a Facebook community, an Instagram community, to share with you and all the other students the news and the opportunities of MathWorks, to know new part of the software and to learn new stuff. And the other point that is our goal today is to do presentation and organize events such as this one. So we try to teach to you and to share with you our knowledge and what can be some helpful use of MATLAB that sometimes is not very trivial, like this time with App Designer. So, if you haven't already subscribed our, let's say, social network and community, if you want, there's the QR code, or you simply search us on Facebook or Instagram. And of course, we are talking, but it's very important. So, if you don't register, you don't get any gadget. So please subscribe to the groups. Okay. Moving on, for the today agenda, what we are going to speak today is MATLAB App Design, but we have to do some step before to arrive to the real core of our presentation. We are going to introduce you Simulink with Arduino. You may ask why we want to introduce you as Simulink and Arduino. Because today we are going to focus on a case study. We will gonna build together let's say an acquisition board that uses Arduino as acquisition board, and then App Designer to display us all the information. So at the end of our let's say course, you can go home, and if you have an Arduino, you can deploy the code and build your own let's say acquisition board. Okay. So I think that can be very interesting to everybody, also to use some real hardware and not only software and MATLAB. So before, there's a little introduction of Arduino, Simulink and Arduino, then an Arduino board, because of course if we speak to use hardware, we need to know exactly some characteristic of this hardware in order to better understand how to use it. And then the last step will be the deploy of the code on Arduino. Then, after a little break, we're going to focus on the main core that is App Designer. And so on, we are going to see the case study with the App Designer. And then the last will be a little challenge in order to win our prize. And then, at the very last, the last thing that we're going to do is a little, let's say, pizza party for everybody with pizza and the possibility to share knowledge between you guys and us, and let's do a little bit of networking. Okay. So I suppose there's no question about this. So let's move on and focus on Simulink. Another little survey. How many of you already knows Simulink? Hands up. So a little bit more than App Designer, very good. So Simulink is a block diagram environment. What does it mean? It means that you don't have to write a code to type down all the line of the code, but you use mainly blocks and arrow to connect different part of your, let's say, model. Okay, so it's a block diagram. What you can do with this block diagram? Well, the focus of Simulink is that you can use this block to model, simulate, and analyze. So you can build your model, you can simulate it, so you can simply click play and see all the evolution of the model, and then at the end of your model, your simulation, you can analyze what is the result. And the key point here is that it's a multi-domain system. It means that you can, in the same workspace environment, model control part, mechanical part, electrical part, all together. And this is very, very helpful because if you have some complex environment, some complex project, this can easily, let's say, slow down the complexity of your model. Okay. And the last part is that it's a model-based design. So it's think, developed, and you can work on it, trying to build the real model base of the design. So, like in this image, you can see there's a little car that simulates the behavior of the car, and then this other block can, let's say, be the control system of your car. So in the same environment, you are going to put this that is the model-based design of your car, and then this is, again, your control action. So it's very, let's say, can be applied in very different topics, okay? And speaking more deeply about Simulink, we have to see a little bit about the interface and how the program itself is, let's say, what is the Windows and how it's, where are the different components, okay? This is until the latest release. So you have the control board here on the top with the different, let's say, button, and then the bigger workspace. And as I said, this is until the 19A. If you have just loaded the latest release, you're going to see these different type of visualization. So you will have a taskbar and a lot of, let's say, different tabs on the top. So I don't know which version you have, but this is the two main difference. At the end, there of course the workspace that is the same in the both versions. I said that you're going to use the block in this environment. And you may ask, where I can find all this block that you speak about? Easily, you can go in the library browser of blocks. So, if you go here on the top of your Simulink part here, you can select this button called the library browser. Inside this application, you will see all the different families of blocks. So here you can select which is the right family of blocks that you want to select. Let's suppose you want signal routing, so some type of control of your signal, I don't know, control system, some 3D animation, I don't know, you can select the family that you prefer. And then this is the second part is that inside one family there's lots of different blocks. In this case, we have just selected the family that is called Simulink support for Arduino, motor carrier, and there's this specific block inside this family. Okay. Why is it so important to know that there are so many families? Because usually when you want to simulate something or build your model, you have to know that lots of complex structure probably are already implemented. So if you want, I don't know, to put inside a controller of some type, you simply search here the type of controller, and probably there will be something already implemented in MATLAB. Also, this can be also seen in the Arduino side. I mean, if you want to do something with Arduino, you simply select Arduino and see what are the different blocks available. Okay. The point is now that if I want to program Arduino, that is something out of your computer, you have to create your code and then deploy it onto the board externally. Okay? And this point is very easy with Simulink because you can select two main types of deploy of the code. The first one, called external, is that you have built your code and you want to run the code on the Arduino, but you want to see which are the different, let's say, behavior of the code inside the Arduino, and also see the data that are going around in the code. So you have to select the external mode. So you generate the code, but you keep connected it to Simulink. This is the core of the external mode. And it doesn't work if you disconnect the Arduino from the PC. Okay? Instead, you want to build your code, deploy it on Arduino, on other code, and you want to leave it working alone in some way, I don't know, far away from your PC. Okay? So you have to select the second option, called the deploy on hardware. This time you generate the code, you build a code that is executable on the Arduino, and you deploy it on Arduino, and you no longer need Simulink. And I think that these two types of application cover all the possible use of the code on the Arduino or other code. As I just said, with the latest review of Simulink, they have changed a little bit the interface, but the focus, the key point is the same. You only have to do a little bit of a different procedure. Here you have to select external or this button. Here you have to do this little procedure, and then you can select this build, deploy, and start. So don't worry, if you connect the Arduino, you will see this explained in your environment. Last point is that I speak of Simulink, but let's say the mother app is MATLAB. I can use Arduino with MATLAB? Of course you can, but there are some differences, and these differences are written down here. So with Simulink, you can build the code and deploy it standalone on the Arduino. So once you have built your model and you have decided what you want to do with Arduino, you can deploy it on the board, and then it can go far away and work autonomously. Instead, with MATLAB, you have to keep connecting it to the computer, and I just write down here. So this is the main point, the difference between the use of Simulink and the use of MATLAB related to Arduino. Okay. Have any question about this part? Maybe I have gone too much faster. I don't know. But if you try to use it on Arduino or any other type of board, you will see that this is let's say a straightforward type of thing. You need to that your board has to work away. You do one, let's say, one procedure. You have to work with your board attached to the computer. You have to do another procedure. Okay? Once you try it, it became very crystal clear. Until now, I speak a lot of Arduino, but as I said in the agenda, we have to understand more deeply what is Arduino and why we choose Arduino to do this type of operation. Well, the first, for the second question, is very easy, the answer. We choose Arduino for two main reasons. The first one is that a low-cost microcontroller. So it costs around some, I don't know, 20 euros, maybe less. I don't know exactly which type of Arduino you want to choose. And the second point is that it is very, very well supported from MATLAB and from all the community that is behind Arduino. So these two main, let's say, topic and are why we choose Arduino in order to do this type of presentation. Okay? Moreover, is widely used in research and, let's say, academic use, and also there's a lot of people, the community, maker community that are very, let's say, actively working on Arduino, so it's very, very supportive. Okay. Usually, if you already know Arduino and any other type of board, they come with an IDE, so an interface in order to program and to write the code. Of course, this has some drawbacks. So it needs to be coded in maybe C, C++ code, that sometimes it is not trivial. If you want to build some complex application and you have to build some, let's say, recursive equation, I don't know what you want to build, that can require a lot of code, lots of struggle with some error that the code can give, some commas, some, I don't know, very, very hard problem to solve and to struggle with. As I said, we decide to use Simulink because we don't have to program, we don't have to have programming skills, and we also can see the model in this, let's say, complex and complete structure. Here you see like 20 lines of code. Here you can, with one lookup, you can see all the model. That can be very helpful if you have to deal with complex model, okay? So this is the two main type of programming that can involve Arduino and that you can use with it. Okay. Moving on, I said of Arduino, I said there's lots of type of Arduino, but now it's time to see which type of Arduino we are going to use. Here I have the two main, the real Arduino, but of course to be more clear, I want to show you with the slide. The first one will be an Arduino called the Maker 1000, sorry, that will be our signal generator. So something that generates our waves, okay? The second part will be the signal acquisition, and in this case we will use an Arduino Uno, okay, one. Again, this will convert our analog signal into something that the computer can read. Okay, I will explain it better very soon. We need some cable in order to connect the two Arduino, and then we need the signal elaboration, so a PC or a Mac that can handle this type of, that can handle MATLAB. Okay. And here you can see some, let's say, 101 code classical stream of data. Okay, and this will be our workflow with a USB cable. Okay. So, characteristic of the different Arduino. Arduino Maker 1000 is this board, has lots of analog pinout, has lots of digital pinout, I/O, input-output port, and a Wi-Fi module. We will gonna use only the analog pinout because we want to build some type of sine wave that can be then analyzed from the other Arduino. And this is the characteristic of the Maker 1000. And we see that has some microcontrollers that are quite powerful in order to produce something that is that goes up to some, let's say, hertz of frequency. Let's put it this way. The other board, that is the Arduino Uno, will be our interface between the analog board and the PC. This Arduino is a little bit less powerful than the previous one, but it has this analog I/O port that will convert the signal. Again, here there's a little bit of say characteristic of Arduino, and we see here that is a little bit less powerful, as we can see from the clock speed. Okay, I don't know how many of you have already taken a measurement course, and how many of you knows how to convert some analog signal into digital signal. It's a question. Some one of you have already taken a measurement course. Okay. So for you guys, it's a little bit of repeating, but for the others, can be helpful to understand better what we'll do on the different Arduino. Okay. Here we are. If we have here a quantity that is analog, we have to do some type of discretization. So to decide how to, what is the digital value of the analog quantity. Okay. In order to analyze it, you can see here we have some type of, let's say, process that can converge to the real quantity, the analog quantity, in order to decide which is the final voltage. And this final voltage will be some number that the Arduino will know in digital, so that can know exactly the quantity and not some physical voltage. Okay? And this is the information that is important in order to know exactly how to convert some type of analog world to some digital information. Okay? So the quantization will be how much is the resolution of the quantization. So if you, let's say, I can draw a little bit a sketch in order to better understand. Okay? If you have like our sine wave, okay, and you have a sequence of steps that in our case are the sampling rate, okay? So how many samples you can take, how many fractions you can use to divide one period. In this case, you have in Earth, so it's a frequency. The other point is use the quantization. The quantization is simply, if you plot it into this space, how many steps you have on this axis. Okay. Of course, it is a little bit, let's say, on the didactic side. It's only a drawing, and this is the different quantity. So you can find here the different values. This is the continuous sign, and this is the analog quantity, and this will be our digital quantity. So this series of points, okay, and this period moment will be acquired, as I just explained, with this type of process. Of course, I'm only trying to briefly highlight how the conversion works. Of course, your professor of measurement will be very much more complete than me. The important thing at the end of this slide is that we will use 8-bit information, so we will have 256 level here, from here to here will be 256. Okay, sorry. And then we will have some frequency in order to scan the number of points that we can acquire. Okay. The important thing at the end, after this information, is that for us in Simulink, we don't have to struggle with how to implement this import. We simply search Arduino and then input, and we will find this one, this block here. This block here is the key point, because this block will perform what I just explained, and we don't have to need to know how it works, because it works. So it will be put inside our Simulink, and then it will give us back the digital information. Moving on, there's the opposite side. The concept is similar, but is switched. So we will generate the analog quantity with a DCA, digital to analog converter. And again, we will have a Arduino block in order to do this. Okay? With some special equation in order to adapt our value input to the real physical quantity. So, if you have any question about this, please, this is one good moment to ask about this conversation point or how Arduino works, or I don't know, if you have any questions. If you have not, we can move on to the case study, and I can show you how to program the Arduino very briefly, and to put the code that I just tried to explain you on the Arduino. Okay.
The Arduino library is not the whole.
No. Yes, you are completely right. As you know, probably, once you try to install MATLAB, you have to select many plugins. You can select many things. One of which is the MATLAB, the Arduino support package. So if you don't have already downloaded, you can go on add-on manager, and then you can search Arduino. And again, you have to select the Simulink support package for Arduino, because there are two main MATLAB support package and Simulink support package. In this case, we will gonna use Simulink support package. Okay. Any other question? Okay. We can move on and speak about a little bit of the case study. I can show you another couple of slides, and then we can go to the Simulink. Okay, so you can understand better what I'm going to show you, and then move exactly to the Simulink. As I said, we have the signal generator, we have the signal acquisition, and then we have the real application. Okay, but I know that I have made some confusions about MATLAB, Simulink. Before I pick MATLAB, then I pick to Simulink. How to better highlight and clearly clarify what we're going to use. Okay, with this little table. So, this part here, so the signal generator, will use Simulink. This part here, the signal acquisition, will use Simulink. And the last part, the focus of today, will be the MATLAB App Designer, so MATLAB. Okay. But speaking of Simulink, we have to build our model. I leave here this slide with all the data, but it's only to show you that all that I'm going to show you with the real Simulink is already on the slide, and you can redo it at home very easily. Okay. So focus on this slide for 1 second. Okay. Now we switch back to the real computer and to Simulink. Okay. How to start up Simulink? Well, there's this big button here we call the Simulink. We simply click it, and there's this big page that where you can select which type of preset of Simulink you want to use. In this case, we're going to use a blank model. This blank model will introduce us into the workspace and to the working area here. Okay, now I show you my ideal workflow, but of course there's different type of approaches to this type of generation of the code building. Okay, we can open the library browser.
One question: are you going to submit the slides and the files?
Already, I think it's not online. After the presentation. Okay. This is our Simulink library browser. Okay. If you go on the family side here, you can go down until the Simulink support package, where you can find different type of blocks. In this case, we're gonna use common utilities. Okay. I did not say to you that this is the part related to the signal generator. Okay, so we need an analog output, so something that will produce a physical quantity that is analog. And in order to put inside here something that is that can be generated, we need to perform here and to put here something that is, let's say, some mathematical quantity equation that can model what signal we want to display. Okay. In this case, we're gonna put a sine wave that can be then output from the Arduino. So I start here because this is the block related with Arduino. Of course, you can start in the opposite way and put before the signs. Let's find out what the size is. So resources, okay. Sine wave, perfect. Yeah. And this is the two main blocks. As I said, a sine wave here, and the Arduino digital to analog converter. We cannot simply connect here to here because if you remember, there was a slide that tells us that there was a relation, okay, between the input of the sine wave here and the real quantity. I mean, you cannot put the quantity, let's say that it's a volt between 0 and 5 volt. You cannot simply build here a sine wave that goes around from 0 to 5 because it has to be converted. So, which are the steps in order to convert this quantity? First of all, we said that this quantity here, if we double click it, want as input something that is an int 16 value. Okay, so an int 16 value means that you have to search something that does some operation called casting. And then I don't know if how many of you knows what is casting. It means that has an input some type of quantity, like I don't know, an integer number, and gave us as output some other quantity that has the same, let's say, value, but in another format. Okay. In this case, we want to have something as output that is an int 16. Okay. Sorry. So now we can convert it to this one. Okay, right. Int 16. And then we have to perform some type of conversion here. If you remember, there was a formula, but in our case, we can simply, let's say, to be more clear, this is the overall computation of the formula. So the sine wave that I just said, and then a conversion factor in order to have the boundaries between the top of the sine wave and the bottom. So a scaling factor, let's call it scaling factor. That is 380. Also because it has to be something that is quantizable. So this scaling factor is to have the correct number of levels as input to the digital to analog converter. Okay, so this is, let's say, the easiest way to have something as output to from our Arduino. Okay, so a sine wave, a conversion factor, the conversion from some type of data to an int 16 that is the type of data that we want as input, and then the digital to analog converter. Okay, once you have understood this, you are ready to go from to generate the code. Of course, the let's say, the suggestion that I can give you is that not always you have to, you are right on the first try. So let's say that we build this and we don't know that there was a 380 as a scaling factor. You can try to deploy the code and then see if something works or not, and then you can do a little bit of debugging in order to see where are the different errors. So don't worry if you cannot do it at the first try, okay? In our case, we have already prepared the code that is here, and we have the two sine wave, a block that does the addition, the sum of the two waveforms, the conversion factor, as I said, the casting operation, and then the digital to analog conversion. Okay. If you cannot follow me straight away, yeah, okay. And also, one other important thing is that I can draw it on the blackboard. Is that the quantity Arduino, the analog signal, I do this sketch here around the 0. The point is that Arduino cannot do this. It must read the quantity that are above 0, so positive quantity. So we simply have done also another operation that is let's say we have added a constant quantity to put it above the 0 level. Okay. And you can, I did not show you what is inside this sine wave. This is the sine wave number 1. As I said, amplitude of 1. This is the bias, so the factor that puts our sine wave above the 0 level, and this is the frequency, and so on. Okay. I was saying that if you cannot follow me straight away here from the code, we will upload all the presentation and also the code later on some type of sharing on. I cannot say BIP because we cannot have access to BIP. Let's say to Facebook, to the community. Okay. So if you are subscribed, you can then see our presentation and our models. Okay. Moving on, we can speak a little bit about the other part, that is the digital to analog converter, that is a little bit more simple. Again, is a block here to read the analog quantity. Again, a conversion factor, and then the serial communication to the PC. So some type of let's say way to deliver the information from the PC, from the Arduino to the computer itself. Okay. And this factor here is because, I don't know if you remember, again, we said that the Arduino reads quantity of 10 bits, but we want to transmit less quantity because it's more faster. So we put here this conversion factor in order to reduce the quantity. But the main point is that you have this part here that is the acquisition that performs the conversion from analog to digital quantity, and then we have this second part here that is the transmission from Arduino to the computer. And as I just said at the beginning of the presentation, here on the top you can find the build and deploy button. Of course, I have not connected Arduino, so I cannot do it, but there's here the button in order to do it, to perform. Okay, here on the left you can see a taskbar where you can select which hardware you want to connect, because of course MATLAB can support different type of Arduino. In this case we are going to use 2 types of Arduino, but of course in the catalog there's many type of board, so you have to select your the correct code for your real hardware. Okay. Okay. Moving on, we can finish the part of the presentation with this slide. That is the slide related with the signal conversion. So we have the input waveform, we have the code that I just showed you, and then we have some type of digital information that goes from the Arduino to the computer. And this concludes the code demos part, and then now it's a little time of break. So if you want, or if you want to go straight away to the second part.
Voting straight away. Yeah.
Okay. Okay.
Straight away.
So my part is over. Thanks for listening.
Okay. Okay, guys. The point is now how to implement the part of reading function inside a MATLAB app, because actually it is the core of this today's lesson. So, App Designer is a toolbox for MATLAB that want to implement your code, your normal code that you can write in a MATLAB script or in a MATLAB function, but in a visual environment that gives you the possibility to share the app with other people that don't know your code, of course, and to execute it without having MATLAB installed on your PC. So it's quite powerful for this reason. Imagine that you have to process some signal, like we will do in a moment, but of course more in a more difficult signal, not this one. And you want to share with your work group your code that give you the possibility to analyze your signal and to compute some information about it. But your work group do not have MATLAB installed on all the computer. You can share your app with all of the people that you have in your group, and all of them can use your app without installing anything, except for a little part of MATLAB that is the MATLAB core. But I will show you this in a moment. How it is MATLAB App Designer? You can actually start MATLAB App Designer if you want. Is on the top left in the MATLAB window, in the app category. Okay, so you can start it and you will see this interface. Okay, so a blank space where you can put your graphical elements. Okay, in the left part you will see some elements already inserted, like buttons, graphs, and so on. So all of the graphical elements. And in the right part here, there are the properties of all of the elements. So when you simply drag and drop your element from there to there, okay, you will see there all of the properties. So color, font, dimension, and also a very key point that is the callbacks. So the callbacks are the name of these blocks for the MATLAB environment. Because of course, if you want to build an app that is of course integrated with your code, you need to call these particular blocks inside your code. It's obvious, I think, okay? But this is the graphic interface. The other interface is the code interface. You can simply switch between the two interfaces with this button here. In this place, you can switch between graphic and code interface. What we see is a very long list of code of instruction, but most of them are in this with this more gray background. Okay, there are white spaces and gray spaces. What are the difference? Gray spaces are automatically compiled when you drag and drop your elements. Okay, MATLAB already know that these elements need some initialization function and also some global variables, and so it actually compile for you this part of the code. You don't need to modify it. Actually, you can modify it, so you have to let as they are. Instead, this white space is where actually you put your code, okay? You take your MATLAB script that do whatever you want, you simply copy and paste in this blank space. It's very easy actually. Of course, we will see in a moment when I will show you the demo. The main point is that you need to interconnect the code of your previous MATLAB script with, of course, the elements of the interface, because you want, for example, when you push a button to run some routines, or for example, you want to plot the graphs and so on. So we will see how to interconnect these two parts. Okay. This is the option bar in the graphic interface. You can see here the settings for your app and run on local machine. In this case, this play button is not a deployment of the app, but it is simply a temporary execution. I mean that if you want to test your app, you don't need to, of course, build the app, but you simply click play and the app starts up. You can also see the debug in the command window, okay? And so you can debug your app before actually deploying it. In the code interface, there are other type of setting. The customizable code are some functions that we will see in a moment when I show you the code. And here are the code setting, very easy, like to change the indentation and so on. There are some properties that I will show you in a moment. Here we can see in a bigger view how it is divided, the graphical environment. Okay, you can see here the available components. So all of the components that you can simply drag and drop. There are some static components like labels, of course, that you need to better explain your users how to use your app. But also lamp, gauge, indicator, of course signal indicator, so graphs, buttons, and all of the types that all of the input and output you can imagine for your app. Okay. Here the workspace you take and drag and drop, and here the switch that I showed you before. Here, as you can see, there are a lot of properties that you can change about your elements. Okay. For example, let's think about this selector. It's a rotating selector. There are label here. Label is important because it's the name of your element. You will change the properties of your element using this name. Font that is used in the labeling around. Interactivity, position, and callback here that I will show you. Callback is when I do some action, what I have to do, what the code have to do. Okay, so when I click the button, what the code have to do. Is clear for everybody? Very, very simple actually. So here are the properties, okay, as I said, and the switch. Here is the interface of the code, okay. The interface of the code, as I said before, these are the parts that you cannot modify, okay? Whereas this white part are the parts that we will write together, okay? When we will write our app. As I said, fixed code, custom code. This fixed code is editable only if you change the graphical element, okay? Is done because of course, with this level of easiness, if you give me the terms, I mean, you drag and drop, and so MATLAB has to maintain some part of the code fixed in order to be able to perform its action. Okay, it's not a code that you write and you execute. It's automatically compiled code. I don't know if you use the other program that use this very high-level approach. You can never modify the code because, of course, it is not readable in most of part. Okay, it's very difficult to modify a code auto-generated. It's clear. Okay. and this is the switch. Okay, these are some of the main functions in the code part. Now I explain to you why they are important. Callbacks, this button here, are a part of the code that is executed when you perform an action on the app. So when you simply pass through with your mouse an area, when you click some buttons, when you change a values, whatever you do in the app, it calls a callbacks, okay? A callbacks that we will have the name of the element that you touched, so button number 1, push, so it means that someone pushed the button number 1, and so you can write the code correspondent to this part. Functions are function, like in MATLAB, nothing different. I mean, if you need a graph that automatically you update during the time, you simply write a function that executes from the start to the end, till the end of the run of the app, and that's the way to do this. Properties are very important because, as I said, for example, a button, you press the button and execute the code. But suppose that when you execute the code, you want to change, for example, the color of an element of the app UI, okay? It's very easy, like a lamp, a LED, or so on. So you create a property that is a global variable that integrates the color of this element, and when you click the button, you will modify this property. This property is accessible from all of the code, so all of the functions, so you can modify interactively in the code. App input argument, we don't need this part, but actually are some functions that are executed in the startup part of the app. Okay. Last but not least, before starting to coding, is the share button, of course. There are 3 different possibilities, okay? You finish your app, you test your app with the run button. Your app is working very well, you want to share it. How you can do it? MATLAB App is a package, you build a package where actually the app is runnable only on MATLAB, okay? You know that in the top part of MATLAB there are some apps like Pin Tool, image analysis. You don't use it, okay? There are some apps. There is a tab that is called apps. If you build this in this way, you will install the app in this top part, and after that you can recall and use it whenever you want. Of course, it is usable also by the other users of MATLAB. Web app, very interesting. Actually, it compiles an HTML file that you can use online. Of course, this part has some limitation because not all the functions are integrable in the MATLAB app. And the last one, very interesting, is the standalone desktop app. What is this? You can build an app that is runnable by everyone. So whether you have a Windows, a Mac, whatever you want, and also without MATLAB, okay? The first time you will execute this app, MATLAB will download the app will download the core of the MATLAB, the part that used to execute the code, and after that you can use this app in your PC without having MATLAB installed. Okay, it's clear for everyone. Okay, so now I think it's better to have a little break. I have to switch the computer. Take 10 minutes, 5 minutes, and after we will restart with the coding part. If you start the MATLAB App Designer, we can write together the code. Okay? Great. Thank you. Okay. Now, if you want to follow me, we can write our app. So, let's start from the let's start from the startup of the design app, okay? Normally you are in home, okay, here. If you go in apps, design app, okay, you start here, you can see me, can you see me? Okay, you start your environment. Okay, here you can see different type of pre-selected app. You can select whatever you want, it's not important. Here you can find some examples, okay, if you want to see how you can use this toolbox. You will see this two-panel app with our auto-reflow. What does it mean? It means that if you have a stricter screen, it auto-reflow your app without losing the disposition of your components, okay? Okay, we can select this. As you can see, there is nothing in your app in this moment. We can fill it with our part. So let's start. We want to build an app to, of course, collect data from Arduino. So the first thing to do, of course, it is to insert a graph. Okay, axis. It is the graph. You simply drag and drop axis here. Okay. This is the first graph we will see. Okay. As you can see, if you select this, in the right part there are lots of different labels and properties, as I said you before. First of all, in the top part there is app.ui axis. This is the name of this particular axis. So whenever you want to modify them, to change them, you have to call this name, app.ui axis. After that, we have the title, so we can call it signal. X and Y, in our case, will be time, and Y will be volt. Okay? Of course, you can rearrange better when you have time. In our case, we will see a time of 56 seconds. Okay, so we can go here in rulers. X lim is 0, 1. It means from 0 to 1. In our case, 0 to 51. Only to see the last part of our ruler. Okay, 0, 10, 20, 30, and so on. Epsilon lim, we will see that we will go until 5 volts. Actually less, so let's put 4 volts. Okay, wrong. 1 and 0 and 4 because we go from 0 to 4. Okay, so now we have our plot. Okay, here we can rearrange, we can enlarge the plot, whatever you want. Okay, for example, you can also insert the grid somewhere. Okay, grid here, epsilon and y, so we have a better plot for our axis. Okay. Okay. So what we want to do is when we press the button, first task, when we press the button, start recording the signal from Arduino and plot it in the graph. Okay, very easy. So here we have a button, we call it start. Okay. We place it here. I don't know why. And here you can see that we have another UI figure that is app.start button here in the right part. This is the name of this component. Okay. So let's do the first step. We want to create a callback when we press start. We want to plot this graph. This is our main function. So we click with the right mouse on the button. We select callbacks and click add button path callbacks. Okay. What does it mean? It means that it will create, as you can see, it switch automatically in the code view and create a white space where you can put your code. Okay. Okay. Perfect. So let's write the code. Okay. Now it's not so easy to write the code in this in direct. So let's try. Of course, because my app have lots of different variables that in this moment probably don't make sense for you, but I have to write. Okay, let's write. So app dot. Let's start from the basis. App dot s. We call an app. This app dot s means that this variable with this global. Okay, app dot s. We implement the serial. Of course, first thing to do is to create a communication with the Arduino. In our case, I checked a moment before. I'm sorry, it is very little. You can see it better. Okay. Okay, serial COM7. It means that when you call this function, it will create a connection with the Arduino. Okay, clear? Second part is app.s. We call a function of a serial communication. Input buffer size 1. What does it mean? It means that, as Alberto told you, we want to use 8-bit. It means 1 byte. We want to create a buffer of 1 byte where we can go and read the value of our function. Okay, it's clear what is a buffer for all of you. Yeah. Okay, there is a continuous flow of information from Arduino to the computer, but we access the information not every time, of course. We need a buffer that we write and the app read. Okay, it's clear, perfect. So once we have done this, we perform a try. What is try? Try to perform some action. Try to connect. So we open the connection. Fopen app.s. It means that no, not app.s. Come zoom on. Okay, app.s. And of course, if we can open the communication, so it is very frequent that you cannot open the communication because we use USB that is used by other devices. So we catch the error, so we will perform an error. We close the S serial, so app.s. Okay, app.s. And we can show an error. Okay, error, wrong connection. Okay, this is end, of course, end of the try. Okay, so this first part is very easy. We try to establish a connection with the Arduino. If it is not working, we simply display an error. Okay, so let's try to run this very first step. So we push. Of course, this is the problem because we don't define the S. Is a global variable. We need to define it. So simply property. We define a private property because we want to use only as property is simply S equal. In this case, nothing because we will assign the value with the port. Okay. Simply, you have to define the property because before using app.s. So we will run. We have to save, of course. Save. Bringing together. Okay. I will wait for you. Okay, as I said before, this part is only to establish the connection. Okay, app.s serial COM7 is the communication port of the Arduino, buffer size 1, fopen, and so on. Okay, so now the basic function is to create a figure where we read the data from Arduino and we plot them into the MATLAB figure, okay? So we define Tmax, that is the total time that we want to plot, okay? Ts is tau s is 0.05, it is the sampling time. We have defined the same sampling time also on Arduino because we need to be synchronized, of course, between Arduino and the reading part. I sample the function and I read the same function plotting it. This is only a counter, it don't matter. Of course, I will share you the code after this presentation. I'm sorry for this problem, but I can do not anything. Here it is the fundamental part. This code, H, animated line. Animated line is a function. Who of you already used the animated line? Nobody, okay. It is a different way to draw lines in MATLAB, okay? Instead of defining a series of points and after that plotting the point in a time series, you define a line and you add the point after the other point during the process, okay? You define an object line and you add the different points. So we define animated line up UI axis is the graph where we want to plot our graph. 0 is the starting time slot. And this freed up.s and this number is simply the value, the initial value, okay? Freed is the serial read of your board, okay? We read the serial of the USB from up.s, that is our Arduino. We multiply per 5 and divide it to 255. Why this? Because we have 8-bit 255 level, okay? We want to rescale our levels in the correct scale, okay? We start from 5 volts that are the volt of the Arduino. We have levels of 5 divided by 255, okay? Each level is this value. And we rescale this lecture from bit to volts, okay? This is simply a conversion from bit to volts, very easy. Okay. Now, very important, yeah.
If you want, I found the error in the other program.
Perfect.
It was an and line.
C'è di più?
Yes.
Grazie.
The one here.
Sì, possiamo scriverlo. Proviamo a scriverlo insieme, poi if you have time we can write together after that I will show you the code. Thank you. Applause. Okay, we can continue from this. Of course, there will be other errors. I hope that you can find that. It is also a test for you, of course. And so now we have written only a very simple function, start, that connects to Arduino. So if I start, we can see nothing, but the connection is it has been defined. Okay, we can continue here. So as I said before, what we have to do is define Tmax 50. Okay. We define Ts 0.05 equal to 0, that is a counter, equal to 0, equal to 0. After I explain you what are this part. But the key point is this. H equal animated line. We call our axis, so UI axis, okay? We start from 0 and we start in the y-axis with freed up.s multiplied by 5 divided by 255. Okay. We created the animated line. So now we have to start computing the reading and the plotting in the plot. So the main problem is that when you execute a MATLAB script, you don't know how fast you will execute it. Okay, so we have to synchronize the reading part with the velocity of our code executed, because it can be executed also in different PC. Of course, it will execute in different with different speeds. So we start up a tick that is a block counter. You know, tick. Okay, perfect. And we write a while cycle that while talk. So where while talk is counting is less or equal to Tmax that we have defined, we have to plot our data. What we can do? I is I plus 1 is only a counter, as I said before. We want to take track of our data. We define data of I equal to fread, like before, up.s multiplied by 5 divided by 25. We have seen to a variable I, the t, the talk. What is the talk? Is the time that it is passed from the tick to the current instant, okay, in second. Perfect. Why I am doing this part? Because I have to stop if I am going too fast, okay? If I'm reading too fast, so my computer time is going faster than the actual time, I will read too many samples in my period. So my function will be not correct, okay? So I have to stop. So I write simply this part. Dot minus the I minus 1 with another while that is like a stop. So I continue going into the while until I reach the correct time instant. Okay, t minus ts. Now I write after I t equal to dot minus t. Okay. 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 While this while cycle that I need to write like this, it simply states that if the time between the talk and the previous time instant is less than the sampling time, so it means that the while is faster than the sampling time, I simply wait in this while cycle until I reach the end of the sampling time. Okay, it's not so easy the concept. I want to understand this part. So I have the Arduino that read at 10 times per second, suppose. But I have the computer that is going 100 times per second. Okay, the clock is 100 times. If I read 100 times per second, I will take a different and wrong value. Okay, it's not synchronized. What we want to do with this while is to wait until the time passes and I can read my value, that is the correct one. Okay, it's clear? I hope so. Okay. So unfortunately we have not so much time because pizza has already arrived at the end. And so I will show you the code and we will read together. Of course, as I said, I will share all the code at the end. So when we have done with the reading of the data, we simply write our plot. Okay, it's very easy. This is only more than one because it's unuseful to write before starting. With this function, add points, we add the points to the line, okay, the animated line. We have the object animated line, we add 1 point for each time. We add the points to h, that is our animated line. At the time instant ti, that is defined by the talk, data I is the read of our Arduino. Okay. Draw now is the command to draw the plot in the correct part. Okay. These are only some code that we can read after. After that, only another part, because this app is a little bit complex than the other one. As you can see, we have a 3 button: start, stop, clear plot, that erase all the data. Animate, very easy. You can a label. This is a lamp, okay, a blinking LED, and another plot that is the FFT. You know what is FFT? Okay, is a fast Fourier transform. So we compute the fast Fourier transform of the signal, and we show you how it is divided in the frequency of the signal. Okay, I can show you. This is the code of FFT. Here, we simply take the data that we collect before in the vector data. We perform the FFT on data. This is a computation that if you do FFT on MATLAB are duty. And here we can perform the computation of the frequency vector. Okay, we translate the frequency, the time in the frequency, and after that we simply plot the FFT. Okay, very easy. Last part. You can see here this is enable button. This enable button simply state if you have to compute also the FFT or not. It is very easy. In fact, here in the FFT there is an if check. Okay, check is the value that assume 1 or 0 due to the check button. Okay, but how you can compute this check? Simply in this part here. Where is too much code? Okay, sorry, it was very. I'm tired. Okay, this is a very easy function. Get. You call the name of your checkbox. Okay, app.enable FFT checkbox is simply the name of the checkbox, and we get the value. Okay, take 1 if it is checked or 0 otherwise. Okay, very simple. So this is very similar to a simple MATLAB script, except for this simple part. As I said to you, the other point were the clear button, this one. Okay, we create a callback on the clear button. We simply call this function CLA, that is clear all. Clear all and UI axis are the MATLAB plot, the UI plot of the signal, whereas the other one is the FFT. UI axis 2 is the FFT. Okay, that's all. We can try to start together. I hope that it's working. It's working. Run. Okay, set up the app here. If you start, we push start. Okay, this is an error. Why? Because I already started the communication with the Arduino, and the communication of the COM is 1 time per time. I mean, you can connect to Arduino only with one app. So what we can do is recompute the start button. Okay, now it has to connect, and here you can see very little the 2 sinusoidal waves sum together. Okay, these are in the time. If we click enable FFT, when we push stop button, it computes the FFT. Of course, it's not a very good FFT because we have not so many data available. Okay, But if you collect more data, it will become very more detailed. Okay. Okay, perfect. So now I will share you the code. If you have some question, come here. Pizza time. Thank you for your participation. I hope that you enjoy this event, and there are also some gadgets here. So if you want some, come and we will give you. Okay. Thank you.